Hello, welcome to the analysis and redesign of the hand juicer by Group 30. For this manufacturing analysis and redesign, we chose this hand juicer. For context, this hand juicer provides a simple and reliable method of extracting juice from fruits, typically from the citrus variety. To extract juice, the user places the fruit into the juicer, then pulls down the lever, therefore squeezing the juice into their desired container. The method of extraction is through a 4-bar linkage design, providing ample leverage to the user. Here is an exploded view displaying the various components of the current juicer design. The primary customer for hand juicers would be people who enjoy juicing their own fruits at home for drinking or cooking applications, as well as bartenders who may need fresh juice for making drinks. The secondary customer is small commercial businesses like cafes and restaurants. The estimated annual production volume for hand juicers is 150,000 units per year.
In our functional analysis, we've decided that juice fruit is the task function, while squeeze fruit and filter juice are the two primary basic functions. In order to squeeze fruit, our product has to apply pressure, secure the fruit, and amplify the manual input force. To filter the juice, it has to collect the pulp from the fruit and guide the juice coming out of the fruit. Next up, we have the primary support functions. To assure dependability, our product has to maintain stability during operation, which means it has to decrease the friction between moving parts, control the motion, and remain stationary or maintain position. In order to assure convenience, it should be easily cleaned. Being corrosion resistant and having detachable parts both help. To further enhance our product, it should be adjustable for various use cases and comfortable to use as well. Finally, incorporating colors into our design helps to please the senses.
There were two prepared assembly sequences for this product, moving from left to right in the fishbone diagram where the picture on the right is the end product. First, we assemble the handle assembly to the top holder, that is the orange, and then we add the extractor. Once that is added, it is added to the column. Then the funnel holder and its subcomponents are assembled. The base and foot stubs are assembled, and everything is brought together. In the second assembly sequence, we start with the base, where the column is added with the stubs, and then the funnel holder is then added, the top holder is then added, the pressing assembly is then added, and then the extractor assembly is then added. After evaluating the two assembly sequences, we can see clearly that the first sequence is a more efficient way to assemble the product.
Next up, we have the function component mapping matrix for the primary basic functions of squeeze fruit and filter juice. And shown here is the mapping matrix for the primary support functions of assure dependability and assure convenience. Finally, here are the remaining two support functions of enhanced product and please senses.
Coming to the bill of materials and cost estimation, most of our parts are made out of aluminum and stainless steel. So stainless steel is for the parts that are in contact with the fruit itself for sanitary reasons, and aluminum is used in the parts which do not require such high structural rigidity and just are there to hold other parts together. We also use steel for the parts that need structural rigidity but do not come in contact with the fruit itself. The parts are usually machined and die casted because some of them have intricate holes and designs that would have to be machined. The assembly process consists mostly of slotting the parts together and fastening them. We have included the material cost, processing cost, assembly cost according to the charts that were given to us in the lectures, and the tooling cost per part as well. And the total cost of the entire assembled unit comes down to $18.467. We have assumed that the labor rate is $20 per hour and a volume of 150,000 units a year with a scrap rate of 5%. The part costs that you see in this slide are estimated from custompart.net, and we also have a manual juicer linked which currently retails for $50. And we have the matrix that compares the functional importance of the parts to the manufacturing cost. So low manufacturing cost with a low functional importance are the foot stubs, base, rod, joint rod, because these parts don't involve any movement. And the funnel holder is a high cost, low importance part because all it does is holds the filter and the extractor, and the rest of the parts fall under high importance, with few of them having low manufacturing costs such as the handle, the rods, and the spine column. But the filter, the top holder, and extractor have high manufacturing costs and high importance. Also, the price of the whole assembled unit as of now is less than 50% of the retail price of a similar product.
The next step of the analysis is the product family design. Here we start to define the functional differentiation table, and as we can see, the functions that are different to customer groups are maintain position and increase comfort. And by re-evaluating the functional component mapping matrix, we obtain the component commonality table. Here the modules are the product parts that cover those two functions mentioned before. As for the product variant, the secondary customer variant has a longer lever and modified base. This would accommodate lower force needed to press the fruit, so the employees would not be easily fatigued, and it allows a larger container to be placed at the base, hence increasing the juice production rate. For the main customer, the product is meant to be lightweight and compact in size.
The common interface between the platform and modules consists of the spine column and the top holder. Basically, the lever attaches to the top holder via the base joint rod, and the spine column is inserted to the base. This is the assembly sequence for the two variants. We immediately have two varieties at the second step. To delay the differentiation, the modified assembly sequence starts with the common interface, the spine column, and the top holder, and then the platforms, such as the funnel holder, funnel, and filter. After that, the base and lever along with other components are assembled.